Welcome to Tuesday Lunch and Learn. I'm James Shore. Every week we choose a software engineering topic, come up with a challenge related to that topic, and then solve it live on stream. And this week it's request timeouts. If you'd like to follow along with today's episode, you can get the code from GitHub, github.com/jamesshore/livestream. Check out this tag right here, 2020-09-15. Your comments and questions are welcome. As always, just go ahead and put them here in the chat, and I will take some as we go. And we've got lots of time at the end for more questions if there are any. All right, request timeouts. One of the way that services can fail is by timing out. So in the last episode, which you can find down here, jamesshore.com/s/LNL, we created we have a microservice client application that runs from the command line, and it actually calls out to a service that does route 13 transformations. And we did really good error handling on that, but we did not handle the case where the server could just pick up the request and then never respond. And this is a particularly annoying thing to have happen, and it really does happen, particularly when a service is under a lot of load. Sometimes it just sort of disappears out into the ether. So we need, in order to have a robust client, we need to be able to handle these server hangs. And typically the way you do that is by timing out or retrying or something like that. Let me illustrate what I'm talking about here. And again, if you'd like to follow along, the code is github.com/jamesshore/livestream. Check out the tag 2020-09-15. And once you've done that, you'll need to install node.js because the examples are all written in Node. But other than that, everything is vendored into the repo. So you should be able to, at that point, use /build.sh to build the code. That will lint and test everything. And we'll let that go. And if you're on Windows, you can just use build, or you can use build quick, which I'll show you. The build will go a lot faster on your computer. It has trouble running it alongside the streaming software that I have. Build quick will only build, lint, and test the files that have changed. And then there's watch quick. Oops. Watch quick will automatically run the build when files change, and it will make a nice little sound like that. Now, once you've got the build working, you can run the server by typing serve and then a port number, and I'm going to use 5000. And once the server is running, you can run the code by saying run the port number and some text. And I've programmed the server to randomly delay for 30 seconds. So as you can see here, it's just not responding. And sometimes it will work, sometimes, and sometimes it won't. Come on, there it goes. Sometimes it will work and sometimes it doesn't. And this is what happens with real world applications, is sometimes they just fail. Charlie Pancakes asks in the chat, would a server outage count as a type of timeout, or is that a different category of failure? Hey, Jitterted, glad you can make it. A server timeout, a server outage is actually much nicer because the server will just refuse to pick up the connection, and your normal error handling will catch that. The timeout is a particularly pernicious type of problem because from your code's perspective, everything is working fine. It's just taking a while to come back. So none of your normal error handling will address it. And that's why it's really important to actually explicitly program in timeouts for those cases where the server isn't responding well. So that is the challenge for today, is we're going to deal with the fact that the server is hanging. Now, the application architecture, for those of you who aren't familiar with it, we've got two pieces here. We've got the command line here on the left, it's backwards for me. And then we've got the server on the right, and we're going to be modifying just the command line. Now, the way the command line application works is we've got the application itself in route 13 CLI. That depends on route 13 client to parse the response from the server. And it in turn uses HTTP client to actually make the request. So that's how things are set up. We need this to deal with a hanging server. How do we actually do that? That's today's challenge. I'm going to let you ponder that for a moment. While you're thinking about that, I want to remind you that this show is made possible by the training and consulting that I do for companies, people who have the capability for a lot of business agility, but not the technical capacity they want. Bring me in to help out, and I work with either a team or a couple of teams with doing training or coaching or even immersive coaching to help them bring them to a high level of competence. Or for larger companies, I actually work with multiple teams, help them work together more effectively. Because as a company grows, you tend to start to see bottlenecks between teams. And solving that is a social problem, it's a process problem, and it's a technical problem. And I bring skill in all three of those to help resolve those problems. If you would like to join the fine people who hire me and make this show possible, go ahead and send me an email, jshore@jamesshore.com, or you can visit me online at jamesshore.com. If you're interested in doing that, but you don't have budget authority yourself, go ahead and drop me a line. I can help you figure out what to say to your boss to potentially convince them to bring me on board, or maybe we'll figure out it's not a good idea. I'm happy to have that conversation either way. And anybody at all, you're welcome to send me a tweet at James Shore. I'd love to hear from you. Let me know what's on your mind. All right, let's get back to the challenge. What do we do if the server hangs? Well, in general, you want to have all your timeouts happening at the application layer. We want to handle the timeouts in the application layer. Now, it is possible to do automatic retries and stuff like that down in your lower levels, but in general, the part of your system that's going to have the information to make good choices about what to do when there's a hang is going to be at the application layer. So that's where the timeout handling is going to happen. But in order to test that timeout handling, we need to have the ability to simulate the hang. So that happens in the infrastructure layer. So we handle the timeouts in the application layer, but we simulate the timeouts in the infrastructure layer. And that is what we're going to do today. We're going to modify our HTTP client to simulate the hangs. We're going to modify Route 13 client to support those hangs so it passes through. Because remember, our Route 13 application doesn't talk directly to HTTP client. It talks to Route 13 client. So we're going to modify HTTP client. We're going to modify Route 13 client. And then we're going to make Route 13 CLI, the application, timeout when the service hangs. So that is what we're going to do. Let's go ahead and get to it. This is not a tremendously long episode today, so go ahead and put your comments and questions in the chat. I'd be very happy to take them as we go, and we'll have plenty of time afterwards if there's extra questions as well. Okay, so what we're going to be doing is we're going to be working in the source directory. Now, this repo is a mono repo of sorts in that it has the microservice here in the Route 13 service directory. We have the command line application here in the Route 13 CLI, and then there's some shared code in node modules. That's distinct from this node modules, which is for third-party modules. This node modules is actually the code I wrote to be shared between the two, the command line and the service. Now, we're only going to be operating on the command line application today. Here we have the actual command line application, and you can see that the way it works is it starts out with a little bit of command line parsing, and then it makes the call to Route 13 client and says, please transform the text for me. And then it writes that response out to the command line. And if that fails, then it writes an error out to the command line. Then that in turn calls into Route 13 client, which using transform async, and that is going to use HTTP client to make the request, and then it's going to do some parsing of that code and return the result. Now, if you're curious about how this is all working, you can actually find the episodes where I did this in our episode archive. That's jamesshore.com/s/LNL for Lunch and Learn. And I wrote the HTTP client in this episode right here, Microservice Clients Without Mocks Part 1. And then the Route 13 client and all of its paranoid error handling is in Microservice Clients Without Mocks Part 2. So go ahead and check that out if you're curious about the details of how these were written and tested. So Route 13 client makes the request of HTTP client, and then HTTP client is what actually makes the network request. And that's, all your standard Node.js networky stuff happening there. And this is where we're going to start our work today. We're going to make HTTP client hang on command. And the way we're going to do that is by modifying the nullable infrastructure wrapper. HTTP client is a nullable infrastructure wrapper, which means that you can actually create a null version of the HTTP client that operates 100% identically to the real HTTP client with one exception. And that exception is that it doesn't actually call out to a service. You can see how this would be handy for testing. And this is part of my microservices without mocks pattern language. Again, if you're curious about the details on that, go ahead and check out jamesshore.com/s/LNL and look for the testing without mocks episode. Or for the details about how we did it for HTTP client, again, this is your episode right here. So HTTP client is nullable. It uses an embedded stub to make that work. So all the same code runs for both the null version and the production version, except the part of the code that talks to the outside world. We actually stub out Node's HTTP library with a little stub right here. And most of the work is happening right here in null response. What we do is we simulate the events that the real HTTP library would provide with some fake events, some stubbed out events. And this right here is what causes the response to be ended and sent back to the client. So in order to make our HTTP client hang, what we need to do is not send the end event. And if we don't send the end event, then the request will never end. You can see that happening right up here. We listen for the end event, and when we get it, we resolve our request promise, which we return from our request async method. So that's what we need to do. We need to modify our HTTP client so that when we're being told to make a request hang, we don't send the end event. And the way we're going to do that is, of course, test driven, because nullable infrastructure wrappers are production code. Even though at present the code that tests, or the nullable code is only used by test, is actually production code. You could actually use the nullable client in your production code. That doesn't happen that often, but it does happen on occasion. And because it's programmed in production code, I wanted to have the same quality as production code. So it all has tests. So we've got a bunch of tests about how the requests work. And then down here at the bottom, we have the nullability part. We say that it doesn't talk to the network. We provide a default response, and we provide a variety of responses that can be configured. So what we're going to do is we're going to add another test right down here. We put it in the right spot. Add another test right down here. We're going to say that it simulates hangs. And let me just make sure I got this working. Okay, there we go. So we are simulating hangs, or we are running our tests. So now what we're going to do is we're just going to follow the pattern that you see here. We are going to make ourselves a null client, and we're going to pass in a response, which is an object of endpoints. And we'll just say an endpoint is going to have an array of potential responses. We'll just provide one. We're going to say that that potential response should hang. And that's enough to create the client. But client doesn't know what that hang option is, so I would expect that to fail. It probably will fail when we make the request. So we're going to need to pass in some options. The host is going to be a host, port's going to be a port, method is that, and the path is going to be our endpoint. There we go. So now our nullable HTTP client is complaining that the response that we've provided, we didn't give it a status, and it wants a status. And the way that's working is down here inside of our null response, I've got this little runtime type checker that I've built many years ago. I'm sure you can find additional runtime type checkers like this on Node. If you want to use, or on NPM. If you'd like to use mine, you're welcome to use it. I don't support it, but it is open source. It's in source node modules, util, and sure.js, and it depends on type.js. So if you want to grab it, feel free. So right now, this is programmed to say that we must provide a number. I'm going to go ahead and just say that that can be a number or it can be undefined. And we'll default that status to, let's say 501 for not implemented. Okay, and now it's complaining that we've got this unexpected parameter, which is hang. So let's go ahead and add that. We'll default hang to false when somebody's providing a response, and we'll also default our standard response to not hang as well. This second one occurs when somebody doesn't provide a response. And then we will add it to our type checker, saying that that can be undefined or a Boolean. Okay, so now we've got the ability to specify the hang, but of course it's not doing anything yet. What we want to do here is we just want to say that this promise, this is actually a promise here, that this response promise never resolves. And I've actually programmed a little assert method called promise does not resolve to check that for us. And so this should tell us that the promise does resolve. Oh, we need to await here, and we need to make this async. Yeah, so it expects the promise to not resolve, but it did. Now this is not built into Chai, which is the assertion library we're using. I have a thin wrapper around Chai, which putting a thin wrapper around your assertion libraries is always a good idea because you're going to come up with application-specific assertions. Anyway, that's here in node modules /util/assert. And the way it works is by going through the event loop a couple of times and then checking to see if the promise was resolved. I'm not 100% sure that this is generically applicable or works in every situation, so use it with caution, but it does work for what we're doing here. The reason it might not work in every case is in some cases you might have a situation where you're using setImmediate in your own code. Pellet says, I guess an interesting thing to test here is how do you know that something will not resolve versus something that has not yet resolved? And that's a good point. If you have a timer, for example, it will show as not resolving, but once you cause the timer to go, you wait enough time for the timer to time out, the promise will resolve. So this isn't the promise never resolves, it's just the promise does not resolve if we go through the event loop a couple of times. So that's exactly what we need right now, and that is failing as we want it to. We expected that promise to not resolve, but it did. So all we need to do is simply not emit the end event if our hang variable is true. And there we go. We now have the ability to simulate hangs in our HTTP client. It's actually just that simple. So I'll go ahead and check that in. Okay, and then we'll go on and we'll do the same thing in route 13 client. So just as a reminder, what we're doing here is first we modified the HTTP client to simulate hangs. Now we're going to modify route 13 client to use HTTP client to simulate hangs. So let's go ahead and do that. Route 13 client, as I mentioned, it uses HTTP client to make the request, and then the bulk of what this is doing is actually all the parsing of that request. But we don't have to worry about any of that. We're just going to come through and again scroll down to the nullable part of this code. It provides a default response, can configure multiple responses, can force an error, and simulates hangs. We'll make a null client. That's going to take multiple responses, and we'll say that the response hangs. And I'll just make the linter pass. And again, it's complaining because it doesn't recognize this parameter hang. So we'll go back into our route 13 client. What you can see here is create null takes the options, which are the pre-configured responses, and it passes them through to null HTTP responses. which maps them to the format that HTTP client.createNull wants. So what we need to do is come down here to null HTTP responses, which is just down at the bottom here. And first thing we can do is we can update the signature right here. So it takes a response, an error, and a hang, which will default to false. And we'll modify our type checking to say that that could be either undefined or a Boolean. So that got our test working. Now we need to make the request. And again, we'll assert that it does not resolve like this. And I have to remember to await that. Okay, and again, it says the promise isn't resolving. Now here, down in null HTTP response, all this is doing is mapping the options that were provided to our route 13 client into a format that the HTTP client wants. So if there's an error, we're going to say the status is 500, the headers, and so forth. What we can do is we just pass the hang option straight through, both in the case where there's an error and where there's not. And there we go. That's all we need to do for route 13 client. It's just that easy. Okay, then lastly, now that we've got the ability to simulate hangs in our infrastructure layer, now we can code our route 13 command line code to actually time out when the hang occurs. Let's go ahead and open up our route 13 code. That is right here. Here's the command line tests and the command line. So what you can see here is that in our tests, we call a run async, which actually runs the code. And the way that works is we create a null command line and we track the standard out and standard error. Then we create a null route 13 client and track all the requests against it. Then we call run with that command line and that route 13 client and return the various things that we were going to want to assert on. So what you can see here is we're running with a particular set of arguments and the response we're expecting. And then we check to see that we actually make the request using the port that we passed in, the text that we passed in, and that the output we expect comes out on the command line. Similarly, when there's an error, we look for output on standard error. So that's what we're going to want to do here. We're going to say that it outputs an error when route 13 service times out. We're going to want standard error. And the args we're going to pass are going to be valid args. And we're going to want to be able to say that this hangs in some way, but I'm not going to set that up just yet. And then we're going to want to make an assertion on it. But let's do this step by step. So the main issue here is that if we tell this to hang, and we await it, then our test is never going to complete. Let me show you what I mean. I'm going to pass in a route 13 hang to be as true. Now that doesn't do anything yet because we don't have a route 13 hang option supported in run async. But we can come down here, we can add a route 13 hang, and we can pass that through to our route 13 client. So now the client's going to hang when we tell it to make the request. So we run the tests, and now the tests hang, which is not any good for us. So what we need to do is we need to actually not await the results of the run async, because the test is we're going to be doing this on a timer, right? We're going to time out after, let's say, 5 seconds. To do that, we're going to have to do a couple of things. One, we're going to have to control the clock, but two, we're going to have to start the run happening and then wait a moment, and then tell the clock to wait 5 seconds, and then check the results. So there's multiple complications here. First, let's go ahead and pass the clock in. So we'll make a clock. And we already have a nullable clock implemented. And again, you can find that in our backlog, jamesshore.com/s/lnl, right here, no more flaky clock test. That's where we made this nullable clock. So we can create that clock and we can pass it into our command line here. And then we can program this so that it defaults to a real clock and allows a clock of our choice to be injected. And we will need to require it. There we go. So we're passing it in, but again, we're not controlling the clock and it's still timing out. So now what we need to do is we actually need the ability to call run async without waiting, which means that we need to modify this so that it returns the results of run async as a promise. And that's a little bit tricky. What we're going to do here is we're going to take this and we're going to say that this is our run promise, and we're not going to await it. We'll just return it. But now all of our tests are going to break. Well, first, this is failing our linting because it's no longer in async. So all our tests are breaking because they can no longer await the run async. So what I'm going to do here is, rather than go through and modify all of our tests, I'm just going to add a new run async, which takes our options. I'm going to have that turn around and call run with those options. It'll await run async or run promise, and then it will return the results. And that should get everything working the way it was before. There we go. And if we take away our timeout for a moment, we should see everything work properly. Yeah. So now what we have the ability, here in this test to run the application without waiting for it. Now we're also going to need the clock. We're going to want to manipulate the clock. So I'm going to return the clock from run right here. I'm going to say, let's advance the clock. I believe that's advanced null async, and we'll advance it 5 seconds. We'll advance the clock, and then at this point we'll expect that the run promise has been resolved, and so now await run promise should work. In fact, what we can do is we can say await assert dot promise resolves. And I expect that will fail because it doesn't resolve. So now we've got enough of a test here to actually program the timeout. So now we can go back to here. What we want to do is we want this rote13 transform async call to be overridden if it doesn't happen within a certain amount of time. And Node.js has built in something called promise.race. We can say promise.race and pass an array of promises, and rote13.client.transform async returns a promise. All async methods return a promise. And that will actually be just the same as calling it directly. And we should see the same failure come out. Everything else passes, but this fails. But now we can also pass in another promise, and whichever one finishes first will be the one that returns its value. So we can just say, let's run timeout async, and we'll pass the clock through. And then in timeout async, we just say await clock dot await async, and then the timeout, whatever that may be, which in our case is 5 seconds. And now our promise resolves. Now we're not entirely done because we want this to fail if we want it to output an error if the timeout happens. So let's do that. Let's say that our standard error is equal to Route 13 service failed, and then service timed out. So right now we're getting nothing, but we expect this. And to make this work, because the way race works is it returns the first, it returns the first result of the first promise, or the result of the first promise to resolve, regardless of whether that's a return value or an exception. And since this code right here, the exception handling code already does what we want, we can just throw an exception right here. For a new error, service timed out. And the interesting thing about promise.race is that the second promise to resolve or future promises to resolve are just ignored entirely. So this error won't cause any problems, even though it will still run. And there you go. That's it. That's all of the code. Let me demonstrate it. I don't think I need to start the server again, but just in case. So now what we should see is on those cases where it's timing out, we should wait 5 seconds. 2, 1, go. And then we get the error. Route 13 service failed, service timed out. Now you notice that the application hasn't exited yet. And that's because the request is still outstanding. And so in order to prevent that from happening, we actually have to go and cancel the outstanding request. But that's a big topic. We're not going to cover it this week. So that is it. That is actually everything that we needed to do today. Let me just remind you of what happened. If you have any questions or comments, I'd love to hear them. Go and put them in the chat. But just to remind you, what we did here is we started out and we modified HTTP client and the Route 13 client to simulate timeouts. And the way we did that was just by modifying the embedded stub to not send the end event when the hang parameter was provided. And once we had that, we were able to modify our Route 13 client or application to handle those timeouts. We did that by, again, we tested it by starting the run, advancing the clock the amount of time that we expected, making sure that it did resolve, and then looking for the error that we wanted. And we programmed it with that promise.race. Nice and simple, but it does have some flaws, and the main flaw that we have here is that we're not dealing with any cancellations. Now, honestly, on a server, if you've got your service calling out to other microservices, this sort of naive approach is actually good enough in most cases. But in our command line application, where we want it to exit right away, it's actually a problem, because even in the case where it's working, we're still waiting 5 seconds. So we need to have cancellation. We need to cancel that timer. We need to cancel the requests. So that is what we are going to look at next time. Again, if there's any questions, I'm happy to take them in the chat. A couple of announcements for you real quick before we get to that. First off, our next episode is going to be next week, next Tuesday, September 22nd, same time, that's noon Pacific, and we are going to be covering request cancellations. We're going to make it so that the request we're making of the server actually cancels. And that's a big, gnarly topic. It should be a really interesting one. And I also want to remind you that if you liked what you saw today, very happy to do this for you, for your teams, for your company. Anytime I do a private session, it's always in your language, using your libraries and frameworks. Often, actually, we do exercises in your real code base, which is a great way of transferring the sort of classroom knowledge to practical, how do we do this for real? If you're interested in that, or would like to talk about how you could talk to your boss about how to bring me in, go ahead and send me an email, jshore@jamesshore.com, or visit me online, jamesshore.com. I work in front-end JavaScript, back-end JavaScript, Node.js. I work in C# and .NET, and I work in Java. Would love to hear from you. Okay, looks like we've got a couple of questions coming in. Thank you for your questions. Um, Lars, Lars says, wrapping your assertion library was interesting. Do you wrap everything to not directly depend on it, or only to extend it in some places, but otherwise you still import and use the original without the wrapper? That's a great question. Let me bring up that code so you can see it. The answer to your question is both. I wrap it so that I'm independent of the underlying assertion library, because third-party libraries stop being maintained, they update in incompatible ways, and I want to have an insulation layer between myself and that third-party library. At the same time, I don't want to implement it all myself. So it is just a thin wrapper. If we look at the way assert is written, it is actually exporting all of the underlying chai library, but then we modify it by making the equal be strict, because the default behavior of chai is kind of dumb in my opinion. Sorry, that wasn't very polite. It's just not useful to do type conversions as part of an assertion. That's just not a great idea. And then I add the additional assertions that I care about. So yeah, I wrap it so we're not directly depending on it, and so we can extend it in those cases where I have stuff that I want to do that it doesn't support. SLS Watt says, new to TDD, I took your repo from a few weeks ago for a new project. Is there a bare version so I don't have to delete stuff, ready to go for new code? Yes, there is. In fact, let me show you. Bring the code back up here. So let me check in what I've got here. If you check out the build branch in the repo, that will give you a bare repository with just the build infrastructure. It does have some of the, it doesn't look like, it does have some of the assertion code in it, but I don't actually, the recent stuff I did with the promises, I didn't put that in there, but most of it's just here in the build branch of the repo. So that's what you can check out if you'd like to start with that. Again, I don't provide support on this, but it is available under the MIT license, and you're welcome to use it. Next comment is from Third Man. They say you can await any object that has a then method. That would be an alternative solution for the run async function. I'm not quite sure what you're getting at there, Third Man. Let me go ahead and bring up that code. So I think Third Man is saying that instead of doing run, I could just call run async. I'm not quite following Third Man. If our other code called await run, it wouldn't work, because what it needs to await is this specific run promise. And if this code right here didn't use await but just called run async, that also wouldn't work, because run async isn't returning the run promise, it's returning its own promise. So you're welcome to try it, but I did a couple of different approaches on this in the rehearsal, and this turned out to be the cleanest one I could find. Oh, I forgot to show you all the code again. I apologize. So what I was saying was that if you await run, it won't work, because you need to await the run promise. And if you call run async without awaiting it, it still won't work, because it's going to be the wrong promise that's being resolved. Pellet says, maybe slightly off topic, but if I remember correctly, it looks like Route 13 client specifies the port and string to modify on the translate requests. Why not pass port on construction? Is it likely to change? There's no particular reason for that, Pellet. It's just because the route, in fact, in other cases, I have done it that way. I've made my clients take the port and even the host as part of construction, rather than passing it on every single request. It just turns out that in some cases it seems a little bit cleaner, but I don't have a strong opinion on which way you should go there. SLS Watt says the watch script automatically plays a sound, and it only works on the Mac and Windows. But it could be made to work on Linux if you add a play. So hey, SLS Watt, if you want to submit that as a pull request to the repo, I'll definitely take it. Okay, that looks like all the comments today. Love to, yeah, Third Man, please go ahead and submit an issue or a pull request. I probably won't incorporate it, but it's really nice to have that as a history. But I think it's happened a few times in the past. Uh, anyway, that is it for today. Thank you very much all for watching. Again, next week is going to be September 22nd. We're going to deal with request cancellation. Really interesting topic and a pretty complicated one. So if you like advanced stuff, be sure to show up. That's it for this time. Thanks very much for watching, and I will see you all next time.